video, it's because you would like help on 17 triangle, where you need to make a model of a precipitation reaction. The one that we looked at in class was the reaction between COCl2 aqueous and NaPO4. So cobalt chloride and sodium phosphate. We mix them together. The question is, what does it make? Now, you know how to do this. You know how to figure out what gets made. Find the ions, swap the partners, use the crisscross method to write the formulas. Step 1, find the ions using our half sheet. You need to find a cobalt ion. Now, you'll see on your half sheet there's 2 cobalt ions. How do you know which cobalt you're dealing with? Well, it turns out that the ion we want is cobalt 2+. And the reason is that, remember in the crisscross method, we're taking the charge and putting that number down next to the neighboring atom. So this 2 had to have originally come from cobalt having a 2+ charge. So if this was COCl3, I would choose cobalt 3 instead. Most of the time, there is no choice. For example, for chlorine, chlorine is always just 1-. Sodium, Na+. Look, there's no Na3 on your table, okay? So you look for the ion that is on your ion sheet, okay? There is a PO4 on your ion sheet. It's on the back here. PO4 3-. Okay? 2 pairs, we're going to swap the partners. Cl is going to go with Na, CO is going to go with PO4. I'm always going to put the positive ion first in the pair. That's just a convention. We always just put the positive ion first. You could have written the COPO4 here and the NaCl here. That doesn't matter. So that's step 2, swap the partners. Step 3, do the crisscross method. Write them without the charge. No charges now. Take the number, the charge number, and write it next to the neighboring ion. So this 3 gets written next to CO. This 2 gets written next to PO4. This 1 gets written next to Na. This 1 gets written next to Cl. If there is a 1, you do not have to put the 1. It's like in math, you don't have to put 1x. You don't have to put the 1 in chemistry either. Another way to understand this is that in order for the charges to equal out, they need to have a certain ratio. So for the 1+ charge of Na to equal out with the 1- charge of Cl, they have to be in a 1-to-1 ratio in the compound. It's just another way to understand it. We want to know whether these are going to be solid or aqueous, so I'm going to use my solubility rules here. Okay, I'm going to scan through the rules for either Na or Cl. I see it in rule number 1, Na, blah, 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 soluble. Okay, soluble means aqueous. I'm going to write aqueous there, okay? COPO4. Okay, I scan through my rules. I don't find CO, but I do find PO4. PO4, other stuff, are insoluble. Okay, insoluble means solid. Okay, so I'm done. Okay, the full reaction, should redraw my arrow to show you that. This is the reactants, and these are the products. And I need to make a model. Your model needs to explain the answer to the question, how does the reaction work? It needs, when it says identify and describe the components, a way that I suggest doing this is to have a key. So it needs to identify and describe the components. That means it should have a key. I can develop a model that represents the system. So your model should show the process. That happens during this reaction as we go from these two chemicals to these two chemicals, okay? And I can evaluate my model. You should say when you think your model applies or when it doesn't apply. One way to do this is to put a key right here. Have a before and an after. In the before column, you're going to draw CO, Cl2, however way you want, okay? It's your model. So if I want to represent CO ion, my CO2 plus ion, as a colored in circle, I can. If I want to represent my Cl minus ion as a box, sure. I just need to make sure I put that in my key. So to represent CoCl2, that's 2 Cl ions and 1 CO ion, all in a compound together. Again, how I represent that is up to me. This would be one way. Make sure you've got details on here. Maybe you remember in class that this has a pink color. Maybe you remember from class that when something's aqueous, it means that water is actually kind of getting in between the ions. You know, and that makes it easy for the CO and the Cl to separate from each other and do a reaction. Okay? You've also got Na3PO4 there. Again, I can come up with, how about the Na plus ion is a triangle, and the PO4 3 negative ion is a pentagon. Okay, and you got your pentagon and your triangle. So Na3PO4, we'll put our PO4 in the middle. It doesn't have to be in the middle. Just however you feel comfortable representing and explaining this reaction here, okay? 3 NAs I drew in one whole PO4 unit I drew, and they're, you know, they are an ionic compound, but it's aqueous, so I'm gonna include the detail that water is getting in between, splitting up the bonds. Obviously in the after picture you're gonna draw the new chemicals that form, and you're gonna need to have arrows that explain, you know, what are the differences, what bonds broke, what bonds formed. I'm gonna leave the rest of the model up to you. But I hope that this gives you an idea on how to start on 17 triangle.